radius. First, we'll get into conical pendulum ideas. This one, T cos alpha minus mg equal to 0. T sin alpha will provide required centripetal force. T sin alpha equal to m omega square r. And then T sin alpha on the block n minus mg equal to 0. T cos alpha equal to f equal to mu n. Determine the lowest friction coefficient mu between the box and the table that prevents the box from sliding. So let me get into this. T cos alpha equal to f equal to mu n. So T cos alpha equal to f. So let me substitute all this one. What is T is equal to? T cos alpha should be equal to mg. And what is f? F should be equal to mu n. Small mg, it is. And there are two m's are there. T sin alpha plus n minus m. Small m, capital m's are there. Just be alert. Small m mu equal to. So what is further n you can replace? Mg minus T sin alpha. So small mg equal to mu, capital Mg. T sin alpha, we can write it as m omega square r sin alpha. We don't know alpha, so dividing these two equations, so tan alpha is equal to tan alpha is equal to alpha is given. Not there, yeah. How to eliminate alpha?
Divide first two equations.
From there, tan alpha, I think we know all the values here. Tan alpha equal to omega square r by g. We know omega, we know r, will g, will get tan alpha. From that, I'll get sin alpha. Then I'll proceed here. Then I'll get expression for mu.
Sir, you took mu n is equal to mg, sir. How did you take like that?
Which one? Mu n. Huh? Mu n equal to the
norm.
Okay, sir. Yeah. Mg minus T sin alpha it is. Mg minus small m. Okay, now what is asking, sir? Lowest friction coefficient. Why that lowest is brought here? Word? Anything we have to further think, or this is sufficient?
Static friction, no, sir. So
Anybody wants to interpret? Oh, answer one. Na? Mu is one. Na? Okay.
Sir?
Yeah.
You substituted wrong, sir. Mg equal to mu into capital Mg minus m omega square r only, sir. Again, you wrote sin alpha. T sin alpha is only m omega square r, no, sir.
Oh, once again I wrote sin alpha will not be there. T sin alpha. Okay, fine. Yeah. If the value of this, if the value becomes less than this, then open equilibrium not possible. Anything greater than this, as equilibrium will be possible. Then the static friction will come. The value becomes more than this, then definitely when the friction will not be sufficient to overcome T cos alpha, then equilibrium is not possible. This is the lowest value is what he's asking. Anything greater than this, okay, fine, equilibrium is possible. Intentionally brought mu what happened for most of the objects around us, what happened will be less than 1. But the situation like this, what happened needs where mu is should be greater than 1, greater than or equal to 1. So definitely I should take care about this particular thing. That's what the question actually. The question is not to test any of our basics. Practically, a situation may